Welcome back. Let's talk about energy and phase change today. Take one of two forms. Energy can either be kinetic or it can be potential. So kinetic energy is the energy of motion. So if something has more kinetic energy, then it has more energy associated with its motion. We talked about how the fact that temperature relates strongly to the kinetic energy of particles. As you increase the temperature, the kinetic energy increases. As you decrease it decreases. And that's really important, that connection between temperature and motion for this part of our conversation. But the alternate piece to that, which is this potential energy, at its most general, is the energy of position. And there's many different types of potential energy categories, and you would have seen those in elementary school and middle school science. But let's start with that basic understanding, and then we're going to focus just on one type of potential energy for our conversation. So with that energy of position, if you think about gravitational potential energy, as you move something from the surface of the Earth farther away, its potential energy increases. And as it comes closer to the surface of the Earth, potential energy decreases. We have some very similar analogies and similar types of occurrences in chemistry. Ultimately, as the year goes on, we'll talk about what causes all of those. But for now, I really just want to focus on the fact that we're talking about the relative position, or how close together, how far apart are our molecules. Yes, there's nuances, and we'll get to those. But in general, we're talking about the relative spacing of our particles for this part of our conversation. Okay, so let's take a closer look at this. So if potential energy is about the spacing of the particles, in a solid, the particles in general are very close together. In a liquid, they spread out more, and in a gas, they're even farther apart. And so what we actually find is that solid, where the particles are closest together, will have the lowest potential energy, or what we're going to call the lowest phase energy for our conversation here. And so when we talk about how energy is changing when particles undergo a phase change, so say from a solid to a liquid or a liquid to a gas, we can look and think about what's happening to the spacing of those particles. As a solid turns into a liquid, the particles get farther apart, and therefore they have a higher energy. As that liquid then turns into a gas, those particles are much farther apart. And so again, we have an even higher energy. But if we were to take that gas and turn it into a solid, we would have much lower energy once we were done. So as we move from a solid to a liquid to a gas, those are going to be endothermic processes because I'm increasing the energy by adding heat. On the other hand, if I go from a gas to a liquid or a liquid to a solid, those are going to be exothermic processes. I'm losing energy, and it's going to have to go somewhere. It's going to go out into the surroundings. So those are going to be exothermic processes. Now, not only are these endothermic and exothermic processes, but we have names for all of these different changes that occur for phase change. Some are going to be familiar, some might not be so familiar, but you need to know what we call all of these different phase changes. So I'm going to clear the ink on this screen, and then we're going to name every phase change. Okay. First off, let's start with the ones you're probably familiar with. Solid turning into a liquid, like when ice turns into water, that's solid water and just regular liquid water, that's melting. When a liquid turns into a gas, we call that evaporation, also called vaporization, but evaporation is fine. And you can also take a solid and under the right conditions, turn it directly into a gas. And that process is called sublimation. Now, all of those processes require putting in energy to separate the particles and increase their potential energy or their phase energy. So those are all endothermic. If we reverse this and go backwards, the other processes are going to be the exothermic ones. So as a gas turns into a liquid, that's condensation. As that liquid turns into a solid, that's freezing. And then if we turn that gas directly into a solid, that is called deposition. In these cases, as we're lowering the potential or phase energy of our system, these are going to be exothermic processes. So in sum, The potential energy of a system has to do with the spacing of the particles. And so the greater the spacing of the particles, the greater the potential energy of the system. And since we're focusing on phase changes, we're often going to call that the phase energy. You also have kinetic energy, which is associated with the temperature and the motion of those particles.